Hello everyone, my name is Carol Handyside. I'm, as Nikki said, a specialist teacher in Dyscalculia. I'm the director of Spot On with Numbers, and I tutor on the BDA's Dyscalculia level 5 course. I actually have, I calculated 19 years experience now that we're at the end of the year, working in maths education. I am really passionate about making children develop number sense and just enjoy maths and find success in mathematics. So as the objectives for this session explained, we're going to look at some of the common difficulties learners have with maths and how we can make maths meaningful, ultimately how children can have success in maths. And I have some practical solutions for helping learners succeed. So just to mention the definition for dyscalculia, that spectrum shows the range of children. So we're looking at, let's say, 100% of children, approximately 5% of learners will have dyscalculia. And it's a specific and persistent difficulty with understanding numbers, and the range of difficulties can be really diverse, but the key point is that it's unexpected and it's not caused by any lack of education or experience. It can occur across all age and abilities. Now, as I said, this is the whole spectrum. About 25% of learners will struggle with maths. They will have maths learning difficulties, but dyscalculia is a specific difficulty with number sense. So number sense is very broad, a sense of number, feel for numbers, but what we look at when we're assessing for dyscalculia is the ability to subitize. And we'll talk a little bit more about subitizing in a minute. Now, it also is involved in symbolic and non-symbolic magnitude comparison. So actually knowing the size of a number, the magnitude of a number as a symbol, as a digit, and non-symbolic as an actual quantity of objects. And I always say, you know, if there are difficulties with any of these, that is going to have an impact on ordering numbers as well, and it's going to have an impact on lots and lots of mathematics. It's the foundations of mathematical learning. So as I said, I discussed subitizing. Okay, so subitizing is the ability to instantly recognize a set of objects without counting each one in turn. So I'm going to show you some dots on the screen, and you're going to see if you can subitize them. Okay, so most people will be able to subitize that set. Okay, there was a set of 4, and you didn't need to count them. You maybe just whatever you saw, you possibly saw 4. Children who struggle, what we know about subitizing is that it is an 8, and all children should be born with this ability to subitize, but they may not make the connection with that quantity of 4 and the word 4 that we use and the numeral 4 that we use to represent that quantity. Okay, and that's perceptual subitizing, small quantities. But it's also important to be able to see larger quantities. So if we were asked to subitize these dots, that is a lot more difficult. That's known as conceptual subitizing, when we have to see a group. Possibly you saw a group of 4 and a group of 3, but then you used your understanding of numbers to know that 4 and 3 is totaling 7. So that's conceptual subitizing, and we'll talk a little bit more about subitizing and the importance of being able to see numbers and actually have that sense of quantity and magnitude. So the important thing that we need to remember is that we think about what are the difficulties, what are the basic difficulties that that children have with maths, and build on that. So we need to ensure that foundations are solid and built on cumulatively. So if a child is having difficulty with subitizing, then we really need to pull back and work on those subitizing skills. Very often teachers will say, oh, you know, this learner is having difficulty with multiplication. But actually, once you start to unpick the difficulties, they actually may be struggling with addition. And, you know, maybe they're having difficulty with subitizing, and they aren't really seeing numbers or conceptually seeing how multiplication works. So this links to Professor Sharma and his intuitive phase of working with a child to help them with their mathematics, that new learning should always be built on intuitive understanding. Okay, so one of the problems with maths is abstract. Okay, what does 3 and 7 have to do with 21? Maths is a very abstract notion. The numbers that we use, the digits that we use to represent numbers are very abstract, and so we need to try and help children to make that connection to the numeral we use, or the word we're using, and the actual quantity. So here we are showing 4 multiplied by 6. We're showing 4 groups of 6, and if we can see that there are 4 and we can subitize the 6, we will have a better sense of what 4 multiplied by 6 actually is, because the way that it is broken down here, we've broken 6 down as 5 and 1, which helps us to make our link to our 5s. So 5 times 4 is 20, and 1, the 4 groups of 1 is 4. So that's going to help build up a sense of what 4 multiplied by 6 is, and 4 multiplied by 6 is 24. So Brian Butterworth is a really prominent researcher into dyscalculia, and in his latest book, I think it's Do Fish Count, or something about counting fish, and actually interestingly they do, well, in a way, he talks about the fact that it's very difficult for sufferers of dyscalculia to just even learn simple addition facts, because they don't have critical numerosity representations of the number. Okay, and these critical numerosity representations are what is, for instance, the number 6, and the six can be many different things. Shaded down there behind, we see 6 as 2 red, 2 blue, and 2 green. It can be lots of different things. It can be measurements, it can be quantities, and that can be confusing to many learners, or for many learners. So it's about making sense of those numerosities. So the solutions that we offer is that using concrete manipulatives helps to make that link to the numerosity that's being represented. So we suggest lots of concrete interactions. There's lots of theorists who have explored the importance of making sense of numbers in the concrete. And then there's the pictorial stage of making of taking that concrete representation and representing it pictorially. Now, that's often overlooked, but the pictorial representation is really important because it gives children a mental record of the concrete experience, and it gives them something that they can then visualize, so that the concrete experiences aren't just things that are forgotten. It helps to have that concrete experience in their mind's eye before moving on to the abstract. And so very often, you know, we teach maths a lot in the abstract, but joining the concrete, pictorial and abstract is going to really help children to get that sense of numerosity. Okay, now there are lots and lots of concrete manipulatives out there. But today I don't have time to talk about all of them due to the time limits of this talk. So I'd like to focus on one representation, and we'll get there in a minute. What I'd like you to do is just think about subitizing this quantity. So it's really difficult to subitize all of these objects. Placing objects in a linear formation is really important in maths because it links to the number line, and we do want children to have that sense of numerosity as a linear representation of the number line. Eventually we want them to internalize that number line. Also, before that, just one-to-one correspondence is when they're counting. It's really important that they it's really helpful if they're in a linear arrangement, because that helps children to keep track of what they're counting. However, it's difficult to subitize, and so very often in schools they will use this Singapore tens frame, and this is useful because again it's a nice linear structure, and it just helps break down that 10, and 10 is a really important number in our number system. We really want children to have a good sense of the numbers within 10 before moving on to larger numbers. But what I would argue is that lots of children are still finding that representation difficult to subitize. And so I'm really passionate about this representation. What did you see in this representation? How did you subitize the quantity? Did you think that that was a nice clear visual of the number 10? And from my experience of working with children with dyscalculia and others, my son, really top mathematician, when I showed him, well, when he was actually looking at a piece of homework in year 3 with the tens frame, and he had to count. He was very efficient, and he counted the 10 here, he counted them in twos, and so he could count that there were 10, but he couldn't necessarily see 10. And I showed him this representation, and I said, how many are there? And he said 10. Why are you asking me that question? Doing much more advanced maths. But it's really useful, and not just for children with dyscalculia who may have that difficulty with subitizing. It's a very visual representation, and lots of children with dyslexia might find it easier to track, and some children might not like it, but I just wanted to expose you to a different way of representing numbers, so that you had something to help build up those subitizing skills. Because what a small piece of research found is that the Hungarian number frame, so that 2-5 dice formation, was really powerful in ensuring that children were seeing and recognizing numbers. So they were found it much easier to subitize when the objects were arranged on this tens frame. They were able to find lots of ways of making numbers, and this embedded their understanding of numbers within numbers. And that decomposition of numbers is really important for early mathematics skills, and it's what we use later on in multiplication, in ratio, in fractions, and so having a good sense of how numbers decompose is really important. And then ultimately what we can do is we can actually teach number bonds through this conceptual subitizing. So conceptual subitizing is about just being instantly able to see that there's 8 there, because we can see that 8 is made up of 5 and 3, and we know that 5 and 3 is 8. And so it becomes a real visual link in order to learn and retain number bonds. Number bonds, or what Professor Sharma also calls the 45 side facts. And the Department of Education states that children should be able to add and subtract fluently within 10 by the end of year 1. And as I said, these are key foundations for later learning. Now, due to commutativity, there's actually not 45 side facts. So as long as we're teaching that commutativity, also if we make links to numbers through ordering and finding one more, we can actually reduce those side facts right down to 16. So there's not a lot for children to learn, and yet still so many children, if you ask them what's 5 at 3, I've had someone I tested recently who just only recently was she able to count on, but even still she's relying on, most children will rely on counting on. We've got 5, 6, 7, 8, but if the children can know that 5 and 3 is 8, they can perform so many other operations. They then know that 8 subtract 5 is 3, and that 8 subtract 3 is 5, and it's really important for their sense of number. And we're not saying that that children need to memorize them. We're saying really important to have a concrete pictorial experience of these abstract numbers, the 5 and the 3, and how they combine, how they compose and can be decomposed. So I really passionate about the 5 and a bit structure, because it links to how we would naturally display our fingers. So 5 and sorry, too much talking. So as I've been talking a lot with my fingers, 5 and 3 is totaling 8. And so not only do we have a concrete experience, a pictorial representation, but also a motor sensory experience of 8, and that multi-sensory teaching is what helps it become memorable. And fingers are also great. Here we have 2 children showing double 8, and they can see that the 2 5s total 10 and the 2 3s total 6. So it's a really lovely visual when we're using that 5 and a bit structure. So as part of the materials that will be sent out to you, I have put together a handout. It will come in PDF format, and there's various Hungarian number frames and a little bit of guidance about how you can explore the frames, and using all sorts of objects that you find. You could use objects that you find on the walk, like these pine cones or some pebbles, or pasta's really useful at home, but we've got lots of teachers, so obviously you've got lots of counters as well that you can use. And in the handout, I've also included a little game from a book that myself and a Dyscalculia specialist wrote on developing a deep sense of number, starting with dots, and it was produced published by the Association of Maths Teachers, and it also includes the tens frame and shows how you can use the Hungarian number frame to link to the more traditionally used tens frame. And another important point to note is that we want new learning to be applied and communicated. So any new learning should, the child should be encouraged to apply that learning to something that they maybe haven't seen before, or something really a real life application. And real life applications are really useful for encouraging children to see the purpose of learning maths, and just to give them, just to take away that abstractness of maths and to make it real and meaningful. So I've got some examples of baking. There's loads and loads of maths in baking, measuring ratios when the children get older. Obviously, money has a real important everyday life application. And what I noticed teaching older students as well is that they really don't understand what 30 miles per hour means. It actually means that we will travel 30 miles in 1 hour. And once they actually know that, then they can work out all sorts of things. Okay, so in two hours they'll travel 60 miles. But there's so much communication that you can have with children around when they're younger, just recognizing the number 30 or number 60 on a sign just helps children appreciate the importance of learning maths. When my son was in reception, I went to a maths evening at school, and one of the other mums said, oh, when we're out and about, we very often read street signs, and we do a lot of reading when we're out and about, but we don't actually talk about numbers, but numbers are everywhere. And so for the teachers that are here, I know there's quite a few of you, including parents in making maths meaningful. They have the opportunity to link to those real life applications, and things like that that evening at school that we went to. It just helps parents to think about maths in their everyday life and how they can talk to their children about maths. And what we know is that 49% of the attainment gap in maths is related to what happens in the home. So, those of you who are parents here, well done. You're already making a huge difference to your child's maths education because you care, you want to know more, and you want to help them. And, that's how you're going to help them. Just, bring in the maths in everyday life, because that's going to make them feel, your children feel engaged and interested in learning maths, because ultimately maths is a very abstract subject. And for the teachers here, you have, the more you can engage parents, or the more you can link to everyday real life applications of maths, the more meaningful maths will become. So my last solution, practical solution, is have fun with maths. People like me who are passionate about maths, maths is lovely. Maths is a fun subject. Maths is a beautiful subject. It's just full of patterns. There's so much beauty and art in maths, but very often, again, we think about it as a very abstract subject. And one way that you can have fun with maths is through games. And I always think games are to maths as reading is to English. And my children both have dyslexia, and they were always really motivated to learn to read because we read with them, and they had that wonderful experience of sharing a book, of finding the joy in reading. And that's what we give as parents. That's what we give to our children. We give them a love for reading because stories are just so lovely. But maths is something that doesn't necessarily have that same appeal because we aren't playful enough with numbers. We aren't, and very often, you know, as a parent, I know I'm terrible. When my son asked me to play Monopoly, I'm like, oh no. It's and I found time to read, but I may not have found as much time for maths games. And maths games are really powerful in the same way that sharing a book is really important. Games give a purpose to learning numbers. So if you are on number 94 in your snakes and ladders game, you know, calculating that 100 take away 94 is 6 is really important, because then you know you need to throw a 6 in order to win the game. And so maths gives a purpose to learning, and in so doing develops your knowledge acquisition, because you know straight away you've done the calculation 100 take away 94, which is pretty difficult calculation. It helps with the magnitude of numbers, because again, you know, 94 is high up on your snakes and ladders game, and so you have a sense of the magnitude of numbers, which we know is a difficulty for children with dyscalculia, and all children would benefit from a really solid understanding of the 100 square, which we'll come to a little bit more in a minute. Now, very often maths work is timed to encourage, and the reason, I mean, it's important in a way that it is timed, because what teachers are trying to do is encourage children to work efficiently with numbers, maybe possibly prevent them counting in ones. But now we have a big problem with maths anxiety, and I always think that playing games provides that intrinsic motivation to work quickly and efficiently with numbers, because the motivation comes from the child's want to calculate quickly, and so they will then find their own quick ways. Oh, I've thrown a 5 and a 6, so I'm not going to count on. I know that 5 and 5 is 10, so 5 and 6 must be 11. And ultimately, you know, games are enjoyment, and giving children the experience of maths as an enjoyable and rewarding subject helps to engage and inspire children, as well as hopefully remove any previous negativity or anxiety. So any games, you know, Monopoly, there's Law with Money, and actually when we play it on the board, there's 10 spaces. So our family kind of know how to jump to the next space on the board, but other ways of learning those 45 side facts or your number bonds is a game like Shut the Box. Is a really great game for developing those number relationships. Okay, oops. Right, so I have a game that's been taken from from one of my resources from Spot On with Numbers. It's both in the games pack and the intervention program, but I am giving it away for free in the handout that we're sending out. So it's called The Last Peggy because it's played with pegs in the games pack and the intervention program. But you can play it with any object. So I'm in the post webinar material. You have various sizes of the Hungarian number frame, and you can play with any objects, as I say, pasta or stones, pebbles, or counters if you have them. And so it's a 2-player game, and we start with 10 objects on the board, and players take it in turns to remove either 1 or 2 objects. Oops, so there we go, player 1 already removed 2 objects. And so we're hoping that they can subitize and say, oh, and so now there are 8 objects left. So player 2 decides to take 2 as well, and they say, oh, now there are 6 left on the board. And so there's so much that we're doing there. We're decomposing numbers into, in this case, 5 and 1. We're also linking to 10, and we're subitizing. So we're saying, oh, well, there's 4 taken off and there's 6 left, so 4 add 6 is 10, or 10 subtract 4. So there's so much learning through this little game. And player 1 takes 1 object, so now there's 5, and player 2 takes 2, and now there are 3 objects left. So player 1 takes 1 object, and so player 2 is the winner because they can take those last 2 pegs. And so that's just one idea I have for making maths and making those, building those subitizing skills of numbers within 10. And what I've also included is a snakes and ladders game. And what you'll notice is that it's designed slightly differently to the traditional way that the numbers weave. And that was intentional. Every row starts again. So, you know, the child just, and my children said, oh no, you can't do that, Mum. That's just, you cannot do that. So if your learner doesn't like the way it's designed, you know, find a traditional version. But this is purposefully done like this so that it exposes the structure in our number system. So 10 more than 1 is 11, and 10 more than that is 21. And it's designed specifically to expose that structure of our number system. An actual fact, starting with 1 at the bottom left and ending with 100 in the top right is not a bad thing. There's lots of math specialists who say it's a really good way of representing the 100 square, because what we talk about in our language is that numbers get higher. And that just really emphasizes the magnitude of the number. So, you know, starting with our 1 to 10 at the bottom actually links to everything that we have in our language to refer to the magnitude of number. So that is great, because then we can play a snakes and ladders game with our 100 square. Now it's, I'm guessing, you know, it's in a PDF, so you can take it away and print it out and cut it up. You know, maybe your learner isn't ready to look at numbers to 100, so just cut off the bottom row and explore the numbers within 10, and they can be explored alongside the Hungarian number frame. And so we know that track games are really, really great for developing number sense. And so we've got our concrete structure, and and a linear representation and the abstract digit. And if you were doing it throwing a dice, so you first threw a 4, you landed on 4, you then throw a 5, we can look at automatically knowing that 4 add 5 is 9. And what I would say in the beginning, you know, children would like to do the traditional 5, 6, 7, 8, 9 and move their counter along the track. But in order to develop those key relationships with numbers and those number bonds, it's really good to encourage them to jump to the next number. So yes, we start off counting on, but the way that counting develops is first counting all, then counting on, and then we know our number facts, so we can make the jump. So we don't want to push this too early. We really want to work with the intuitive understanding of the child. But once they know those number facts, then we can encourage them. We can encourage them to secure and consolidate their learning through the jumps on the snakes and ladders games. And that 100 square, that jumping along the numbers, the snakes and ladders track is really, really powerful for things like times tables. And very often people don't appreciate that it's that sense of number within 100 that children don't get, and therefore are struggling with their times tables. Oh, something else I forgot to mention. So we can cut off this strip to 10, and then we can cut off the next strip of 11 to 20 and see how our 100 square can be joined together to create a number line. So that's an important job. Very often, if children are finding maths difficulty, is because they're not making that link themselves. They're not making, we're throwing too many structures at them. They don't understand the number line, but they do understand 100 square. Well, we need to make that link explicit. So I've also included in the handout a blank 100 square, because there's just so much you can do with the 100 square, and if you're playing the game alongside it, they're developing, they're really sort of internalizing. And what we want to do is we want children to internalize that 100 square, and that just gives them a really good sense of numbers. And once they have that cracked, because that includes our place value, our number relationships, once they have that cracked, they can very often generalize to larger numbers, but that really needs to be secure. And so there's so much you can do with the 100 square. You can use it to link to patterns in multiplication tables. So here I've got the 8s highlighted, and obviously the 8 times table links to the 4 times table, which links to the 2 times table. And so there are just so much. My son, when he was little, he came home, he was talking about, he'd just learned his 8s, and he was talking about the relationship with 2s and 4s, and he circled all the 2s in one color, the 4s in another, and the 8s in another color. And it was just like, oh wow, I can now see all of those relationships, and I can make sense of how my how I don't have to learn a whole new times table, because I already know my 2s and 4s, so my 8s will come next. So just talking about, just wrapping up what we've spoken about, we want to make sure that we have really firm foundations, and I've spoken about number relationships. We talk about number bonds, but we really want children to have number relationships within 10. Talked about how we can extend that to 100 and build on their intuitive understanding of numbers. And then we've spoken about the importance of the concrete pictorial abstract approach, or the CPA approach, to ensuring children understand numbers, and to ensure that any new concept is secure, because they've explored it physically, they've been able to mentally record it, and they can therefore work in the abstract. So maths is really abstract, but we need to try and find ways of making it real, and link it either to real life applications, or just take that new learning and apply it in some way. And then we pour in the concrete. If we're building foundations, in this is sort of like a building analogy, but we can cement all the new learning through communication. And actually, I didn't speak about this enough. I didn't talk about the importance of communication. So it's really important in order for children to conceptualize any maths learning through being able to communicate and explain what they understand. And this is really useful for those parents here, to think about, with maths, it's not about, you don't need to feel the responsibility to teach your child. The best thing that you can do is ask them, what did you learn today? Can you explain it to me? That is going to help them more than being taught maths, their ability to explain what they've learned. And we also cement in that understanding with metacognitive talk. So metacognitive talk is thinking, about processing how they make sense of things. And so the type of metacognitive questions you ask is, how did you know that? Or what did you notice? What's the same here? What's different? And so they can start, once they ask those questions, they can start to make sense of the mathematics. Now, obviously, if the learner is really not engaged, they find maths really miserable, and they not having any enjoyment in the subject, that learning will not be cemented. We need a nice bright day in order for our foundations to be to set, and to feel really positive about the learning, and that will ultimately lead to success in maths. So that was a whistle-stop tour of all of the things, the key points that I could think of sharing with you in a short space of time. And I hope you found something useful that you can take away. But I see that there's quite a lot going on in the chat and the Q&A. I haven't had a chance to look at that, but thank you very much for your time. And now I'm ready to answer any questions, and thank you for being here. Lovely.
Thanks so much, Carol. That was great. Some really simple and clever ideas of just making it more visual for a child. I know I have a dyslexic child, an 8-year-old, who I'm not sure if she's dyscalculic, but I know she definitely struggles with timetables, as many children do. And seeing the number grid with the patterns showing that, I think that's really clever, because even I see it in a different way, because obviously memory can be an issue if you're dyslexic. So just the working memory and how you process that information, I think it's just a simple but really powerful way to try and help with timetables.
Really powerful for all learners. So I spoke a lot about dyscalculia, but any maths learning difficulty will benefit, or any child will benefit from that concrete and pictorial experience, because because that's how we can conceptualize mathematics, and as you say, remember it. And well, my children, I know, as dyslexic learners, are very visual, and so they really respond to a visual representation.
Yeah, exactly. No, that's great. Thank you. So we do have some little bit of time, so, and we do have some questions, as you said. So let's crack on and see if we can get through a few of these. So Claire is asking, she says she has a year 5 child who has made very little progress in maths this year. He's working at least 2 years behind his expected age, and he has been part of interventions and support to support his foundational maths, but they have made little difference so far. He needs an assessment, but whilst they wait for the assessment, Claire is wondering if there's a starting point in terms of assessment that she can do as a teacher to try and identify what might be causing his problems.
Identifying his problems. So I would say going back to some basics, you know, how is he working with his number facts? How is he, you know, does he know 5 and 3 automatically? Is he counting on? That is such a core foundation to understanding numbers. Is he seeing numbers? So you can have a go at all the resources that you receive in the pack. One key, although it can be learned, but asking them to show numbers on their fingers without counting. Can they just show you 7 without counting? And then, well, can you show me 7 in a different way? Oh, it's also 4 and 3, is really good way of testing whether they do know the different ways that numbers can be decomposed, and that can be a key area. 2 years behind, he's probably then struggling with his times tables as well, but you know, or securing number facts and securing numbers within 10 and then 20 and then before moving on to 100 is going to help just get it's very often the case why children are behind in their maths.
Brilliant, thank you. Anne is asking, how overtly do you refer to maths when you're actually playing the games, or do you just leave the child to see what's there? Would you suggest that they actually sort of give the sum, or do you just let them play?
It depends on the child and how they're going to respond to the maths, how maths averse they are, and I tend to be quite subtle, but at the same time using good mathematical language, like 10 take away 4 is 6, and encouraging that does help as well, because obviously we do want them to tie in the language. So perhaps, I mean, when I was developing the games, my son just loved playing them. he was and all children do. All children that I've worked with, they respond well to games generally. I know that the real problem with maths is that sometimes it gets to the point that there's such negativity around maths and such anxiety that the game doesn't become fun. And I've read a book by Judy Hornigold, and you know, this child didn't want to play games because he couldn't even notice the 5 pattern on the dice, so he was very averse to playing games. But what she said is that, you know, through playing, just gently playing games and not putting too much pressure on the child, he did eventually learn to recognize the patterns of the dots, and it did help him just have an appreciation of the fiveness of 5, because he could then see the quantity that was related to the 5. So it all depends on the child, how overtly you want to talk about the math. Obviously, the more maths you can bring into the game, the better, but at the same time, we just do want it to be a positive experience.
Brilliant, thank you. We have a question. Rachel's saying the Hungarian model is great. She says we have a version of dominoes which goes up to 9, but still with the pattern. Would this be confusing to introduce, or do you think it would be okay to start with?
Yes, I mean, there's so many lovely dot patterns, and I do like the 9 in the 3 rows of 3. Some people say there are too many ways of representing numbers can be confusing. I would say this is where you have to start with the learner, start from the learner's perspective. If they are finding it confusing, then we stick to really clear patterns, like the dominoes, the more traditional domino patterns. But what they also know from the research around number sense is that number sense is developed through exploring lots of different representations and making the links between them. So that can help minimize the confusion. If today, we're going to explore 9 in lots of different ways, and some people think, well, that's confusing, but actually it's about making those connections between all the different representations of 9, because some of number sense is about having flexibility. Flexibility is really important in maths. If we say to them, well, they can't see 2 different representations of 9, because then they're going to get confused. Well, then when they go on to learn about percentages, and to know that 50% is the same as a half, is the same as 0.5, well, then they're really going to struggle, because in actual fact, a lot of maths is about being flexible, about being able to say, oh, that's 9, oh, and that's 9 as well, and 50% is exact same as 0.5, is exact same as a half, is exact same as 7/14, that in maths there's so many ways that we will say the same thing. And so if they can overcome their difficulty with the fact that 9 can be represented in so many different ways, it is actually a learning curve that they will then be able to go on and be a little bit more flexible with their mathematics in the future.
Brilliant, thank you. And we've got somebody asking about how to support secondary school pupils with algebra, my least favourite, and 3D shapes. Any tips or games that that will help with either 3D of those?
Shapes and algebra. Now, algebra is the very abstract way that we talk about and generalize all of numbers. So actually, again, it's about those firm foundations. If children understand that that algebra is just another way of working with numbers, then they sort of need to understand how numbers work and how numbers operate. So there's lots. I mean, again, it's about working in the concrete. It's about just seeing algebra as a puzzle. Very often, solving equations is about just seeing the unknown as a missing number. But again, it comes back to that, 4 add x equals 7. It's about having that decomposition of 7. Oh, I know that 4 add 3 equals 7, and so I know that my missing number is 7 take away 4. And so once they have that sense of how numbers are decomposed and how they relate to each other, that's why some children are then able to generalize and work with algebra. But those children that don't have the decomposition of number will really struggle. And in the same way, when we expand brackets, what we've really done is we've decomposed, you know, A add B inside the bracket is just really two numbers that have been decomposed, and we're multiplying it by something. And that is the same way that we would do if we were dealing with numbers in real life. And so there's a real link to real numbers. And I suppose how I deal with algebra is I try to make it as real as possible. I try to link to the intuitive, link to what can they do? Can they say 4 add something equals 7? Can they work that out? Okay, and use that metacognitive talk. How did you do that? Oh, they might even struggle to say that they subtracted, but I'll pull out a calculator and say, what calculation are we doing? And so that they start to explain to you how algebra works. So, you know, starting from the child's from the learner's perspective, and trying to make it link to what they already know, so that they can build on that, and therefore work in the abstract. Sorry, I just
that's great. Thank you so much.
It's a very difficult question, but there
Yeah.
is the session. Well, that's algebra and 3D shapes. 3D shapes again. You know, actual 3D shapes. I made my own. I have my own. Oh no, I'm not going to be able to show you because I've got a background, but I've got my own 3D shapes that I use. But you get some lovely resources where the 3D shapes open out into nets, and that concrete experience is just so powerful.
That's brilliant. Thank you so much. We have actually run out of time, but just very, very quickly, we've got lots of people, lots of parents asking about how to go about a dyscalculia assessment and what they can do. Can we just quickly cover options for them?
So for dyscalculia assessment, I think there's a lot on the BDA website about where you can go. Also, there's the BDA helpline, and there are a few sort of organizations that will have lists of dyscalculia assessors. Just check that they have a APC, an approved practicing certificate, or that they do have the British Dyslexia Association sort of stamp of approval, which is the AMDAD. AMBDAD.
Fantastic, thank you. And like you said, if anybody has any particular issues or want some sort of more advice about their own child, then do go to the helpline. All the details are on the website. You can email or phone, so do use that. That's a free resource. So that is all we have time for, unfortunately. Thank you so much, Carol. For anybody that's interested in other webinars that we're running, all our free webinars are on the website. We are doing another one within this series of Dyscalculia in September. So again, do keep an eye on the website for that. But if you sign up to the free newsletter, you'll get updates on what we're doing anyway. But thank you once again, Carol. Thank you to our sponsors, TextHelp. Thank you, everybody, for joining us. And we will leave you to get on with your rest of your evenings. Thank you, everybody. Take care.